Hi everybody, I'm going to work through a few proportion problems with you. These are pretty quick and easy. I just want you to get the hang of setting them up. These are actually really useful. They come up a lot in real world math. What I'm going to ask you to do is after I go over these, I want you to do the prime numbered problems for your homework and finish those up this weekend. All right, so I'm going to look at a few of these. First one is number 12. The ratio of the width to a length in a rectangle is 3 to 8. If the length of the rectangle is 20 inches, what is the width? So I pulled up just a little workspace here. So I've got a rectangle. The ratio of the width to the length is 3 to 8. When you do these problems, keep a couple of little proportion equations in mind. One of them is part over whole equals part over whole, and that sounds really obvious, and it is. But what that means is keep the right piece with the right piece. The part we'll call, doesn't really matter, the width to the length is the part to the whole ratio. So for our other rectangle, we need to put the same pieces in the right place. So the ratio of the width was 3 and the length was 8. So this other part of the sentence says the length is 20. What is the width? That's what we're looking for. And then we can cross multiply. Again, that's 20 times 3, that's 60, equals 8x. We divide by 8. And I believe we get x is 7.5. So we would say that the length of the new rectangle is 7.5. Whatever it was, inches, I guess, is our units. Okay, so it's part to whole, a part to whole ratio. Next question says, Fred paid $72 last week in gas for his car. If he used 56 gallons of gas, how much did he pay per gallon? This, I think, is an old worksheet because Fred did not pay very much per gallon. So when we say per gallon, that means per 1 gallon. We call that the unit rate. And again, our part over whole, we're looking cost per gallon. So I'm looking for dollars per 1 gallon. And what I know is that he paid $72 per 56 gallons. And if I cross multiply there, that's 72 times 1. And then that's 72 equals 56 times x, or 56 times, I could use a dollar sign as my variable. I divide by that 56, and I get $1.29 if I round. We want to remember we round money always to 2 decimal places. That's 1.2857142, blah, 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 but rounded in terms of money, $1.29. So another real-world question is the question of unit price or unit price comparison when we find out what's a better buy. So the question says a store sells bars of soap, 4 for $3.56 or 3 for $2.97. So we would do, it's cost per bar that we're looking for. So $3.56 per 4, or, so this one is not really an equation, $2.97 per 3, and we decide which one is the better price. We could divide that out. 356 divided by 4 happens to be 89 cents. 297 divided by 3 is 99 cents. So our unit price shows us that this is the better buy. So this one, number 20, is an interesting one in that the way that we're going to set it up. It says the ratio of men to women in a class is 2 to 7. So then of the 36 students in the class, how many were women? So what we know is that the ratio of men to women was 2 to 7. And we know that there are 36 students in the class. So that's 36 if we think about that part to whole relationship. The 36 would be our whole, that's all of our students. And we're looking for the number of women that were in the class. But the other ratio they give us here is 2 to 7. That's men to women. We know that there were 7 women. We know that there were 9 students total. So that 2 doesn't represent an individual number in this problem. It helps us get to the whole out of that ratio. Okay, so if there were 7 women and 2 men, there were 9 students in the class in total. And then we could cross multiply, or I could also notice that if I multiply 9 times 4, I get 36. 7 times 4 would give me 28. women in the class. Whenever we're dealing with percents, this is really the exact same proportion I gave you up above, but we word it a little bit differently. We say part over whole equals percent over 100. And every single time I do a percent problem, I use this proportion. The fact that we have that 100 in there means that I never have to worry about moving the decimal left or right. If you have other ways of doing percent problems, that's fine too. But what's going to happen here is that 100 will always be there. We're going to know out of the part, the whole, and the percent, we're going to know two of those, and we'll figure out the third one. So for example, we have this question number 1. It says, on last week's math test, Carol had 21 correct answers out of 25 problems. So if I'm writing a proportion, I would write my part is 21, the number she got right. The number of total questions was 25, equals percent over 100. And then I can cross multiply. I could put an X instead of that percent sign in there, that's fine. 2100 equals 25X. And then divide by that 25. And X would equal 85%. Okay, that's pretty easy numbers in these problems. You probably could have done that a little differently. I'm sorry, 84%. But that idea of cross multiply is there if you need it. All right, let me hold on a second. So I might solve a question like number 9 here. Mrs. Freeze brought a watch for $45. She was charged 10% federal tax and 4% sales tax. How much did she have to pay altogether? So for this one, the part would be what we don't know. The whole would be the 45. The percent would be, if I add those two percentages together, the percent would be 14 over 100. Now what I'm looking for is the amount that she had to pay in taxes. So this is kind of a two-step problem. What I'm going to have to do first is figure out the amount that she paid in taxes. The question is asking how much did she have to pay altogether. So once we find out how much she paid in taxes, we'll add that on to the amount that she paid for the watch. So if I cross multiply, 14 times 45 is 630 equals 100x. And then I'll divide by that 100, and x would equal 6.3 or $6.30. That's the amount she paid in taxes, in addition to the amount that she spent for the watch. So we would add those two together, the 45 plus the 630. In total, she paid $51.30. Okay, so that part over whole equals percent over 100. It works almost every single time. Sometimes we have to do two things with a percent question, so we have to be careful of that. But part over whole equals percent over 100, then we just cross multiply. I want to talk about one third kind of question, a third proportion related to percents. And that's when we have things that are marked up or marked down or increased or decreased. And again, it's that same ratio. We end up with equals percent over 100. But when we talk about changes, we talk about the amount of change over the original amount. So instead of part over whole, it's a very specific part over whole. The amount something changes by over the original amount. So for example, this question number 8, the PEP club was decreased from 15 members to 12 members. What was the percent of the decrease? Well, I need to know how much it changed by. In the numerator of that fraction, how much did it change by? So it changed from 15 to 12, so it changed by 3 over the original amount. The original amount was that 15, and then equals percent over 100. So that's, if I cross multiply, 300 equals 15x, and then dividing by the 15 gives me x equals 20, and our units there would be 20%. It was a 20% decrease. So anything that is not a composite number. So here's an example of where we use these percent change questions. If we look at things like COVID cases in Worcester on October 20th were 980. On October 27th, we're 1,260. So we talk about what's the percent of change in that last week. So we do the amount that it changed by. So to go from 980 to 1,260, I would subtract those two numbers. I would get that it changed by 280 cases. And then I divide that by the original amount. So it's not 980 divided by 1,260. That doesn't make sense. It's the amount that it changed by, that 280, divided by the original amount, which is 980, equals our percent over 100. And if I cross multiply, 280 times 100 is 28,000, and then I divide by 980. That's a 28.57% increase in 1 week. So since last week, the number of COVID cases in Worcester increased by 28.57%. So that's a significant increase. So that idea of percent of change is a big one. We use it a lot. You'll hear it a lot in politics in the election in the next couple of weeks, and COVID cases. So watch for those things. Those numbers, those percents, they mean something. Somebody came up with a percent somewhere. Okay. I want you to do on that paper, I'm attaching the PDF here, do the prime numbered problems. That means if you are number 2, number 3, number 5, number 7, number 9, 11, 13, 17, 19, any of those numbers on the front or the back of, on either of those 2 pages of the PDF. All right, and we'll wrap that up. We're about finished. We didn't do anything real complicated here. You've done these before. And we will just review Monday, Tuesday. Let's see where we stand at the end of Tuesday, and figure on a test towards the end of next week. All right, have a wonderful weekend. Happy Halloween, everybody. Bye-bye.